Oh, hello Algebra 2 students. Welcome back to my video learning series. This is section 4.5. We're going to be solving using square roots. How cool is that? The essential question today, unsurprisingly, is how can I solve equations by using square roots? I found some hilarious things on the internet. Get it? Ha! These are square roots, like tree roots. I love math puns. Let's get right into the action. We need to solve this equation. Let's think about what a square root is. Remember, a square root, so say for example, if I did the square root of 9, that would be 3, right? Because I know that 3 times 3 is 9. So we know that square roots and squares, these are inverse operations. In other words, I can cancel one using the other when I'm solving equations. So in order to cancel a square root, I can take the square, in order to cancel a square, I can take the square root of both sides. That cancels here, and the square root of 169 happens to be 13. And this should make a lot of sense. Like when I plug back in, what happens when I square 13? I get 169. Except, isn't there something else that I can square to get 169? Think about it for a second. Isn't there another number? I wonder if you thought about negative 13. If I square negative 13 times negative 13, those negatives are going to cancel and I'm going to get positive 169. So not only does x equal 13, x could also equal negative 13. And it makes sense because when you plug it into the equation, you do indeed get 169. So we could either write x equals 13 or negative 13, or you will often see it written like this, plus or minus 13. And this plus or minus literally means, hey, positive 13 and negative 13 both work. Okay, let's try a second example. Now, we're going to get a little more complex, but don't get too freaked out. First of all, we see a square. So I know that in order to cancel that, eventually I'm going to need to take a square root. Remember the square roots back here? All right, so eventually I'm going to need to take a square root, and that'll cancel the square, but you have to be careful. If I do this right now like this, I'm not only taking the square root of this, but I'm also taking the square root of 4. It kind of distributes, and so I need it really to be 2x. Now that's a little problematic, so what I would recommend doing so that you don't make the mistake of forgetting to square root the 4 as well, and then running into complications because the square root of this could be positive or negative, I would recommend using reverse order of operations. When you are solving equations, you're kind of undoing operations, right? And so we typically undo the adding and subtracting first, then the multiplying and dividing, then the exponents. So when I'm solving this equation, it would be really good to divide through by 4 first. So x squared equals 112. Now when I take the square root, I don't have to worry about also taking the square root of a coefficient. Now you could put this into your calculator and find out that the square root of 112 is around, I don't know, 10.5-ish. But we want nice exact answers in this chapter, and that means leave it in radical form. And remember, when you leave things in radical form, you're looking for what perfect squares live within the number. So I know 112 happens to be a multiple of 4. When I divide 112 by 4, I get 28. 28 is also a multiple of 4. 4 times 7. So when I take the square root of 112, really I have the square root of 4 times 7, and I can write that as the square root of 4 times the square root of 4 times the square root of 7, which I know is going to be, hey, square root of 4 is 2, square root of 4 is 2, square root of 7, I don't know. In other words, my final answer is 4 root 7. That's how you read that, 4 root 7. But I know that it could also be negative. So I'm going to write plus or minus 4 root 7. The reason it can also be negative is because whether I square a positive number or a negative number, they both come out positive. So plus or minus 4 root 7. Moving right along, let's look at example number 3. Okay, we have some complexities, right? Remember, I want to move in reverse order of operations. So on my way to isolating this x, let's make sure that we cancel out addition and subtraction first. So I'm going to add 18 to both sides. That gives me 7 times x minus 4 squared equals 28. Should I cancel this subtraction by adding 4 to both sides? No, don't be ridiculous. That 4 is in parentheses. We can't cancel that 4. It's trapped within parentheses. It's basically in jail. So let's move to the multiplying and dividing next, since I can't cancel that negative 4. I'm going to divide by negative 7. So x minus 4 squared equals 4. Hey, I can take the square root of both sides. So x minus 4 equals 2. And finally, now I'm kind of canceling the parentheses. I can add 4 to both sides to get that x equals 6. And if we plug this into the equation, it should make sense. Hey, 6 minus 4, that's 2. 2 squared is 4. 4 times 7 is 28. 28 minus 18 is 10. Nice, it works. But what did we forget? Not only can the square root of 4 be 2, also the square root of 4 could be negative 2, because remember, every time I'm taking the square root and solving these equations, it could also be a negative. So not only could x minus 4 be positive 2, x minus 4 could also be negative 2. And here, when I add 4 to both sides, I get that x also could equal 2. Very interesting. Let's make sure it makes sense when we plug it into the equation. Hey, 2 minus 4, it's negative 2. Negative 2 squared is positive 4, and now I'm right back to where I was when I plugged in 6. Positive 4 times 7 is 28. 28 minus 18 is 10. So 2 answers, 1 arose because the square root could also be negative. Why couldn't we just do this before? Mr. Gregory, this is so much easier than like factoring and using zero product property, or maybe you don't think it is. I don't think it is. I like using zero product property. Why can't we use the same technique here? Here you told us we had to do factoring. You told us we had to do this and this and this and then set and then -1 and 3. Why couldn't we just do this technique of kind of canceling things and taking the square root? Why did we have to do this weird factoring stuff? Well, let's take a look at what would happen if we tried to take the square root here. Probably I would want to get x squared by itself and then take the square root, right? So in order to do that, I would add 2x and 3 to the other side. I'm trying to isolate the square so that I can take the square root of both sides. Now when I take the square root of both sides, I run into trouble. Sometimes people only take the square root of 3 and call it a day. That doesn't really make sense. You should be taking the square root of the whole side. But that leaves me with x equals the square root of 2x plus 3. That doesn't make sense. I haven't isolated x. There's an x over here and there's an x over here. I haven't isolated anything. And that's why we can't use this square root technique for problems like this. Look at the critical difference. Over here, I had just one square, and there was only one x living inside of that square. Same here. There was an x living inside of the square. There was not one of these extraneous x's running around. Here, since I have an x squared and an x, I need to do something special. This square root technique is not going to work. And the special thing we discussed is reverse foiling, factoring. You could also use the quadratic formula. But the point is I can't use this square root technique. And the reason is because I have this x running around. Summary. To solve using square roots, you can't do it if you have an x involved. So this example, can't solve this with square roots. But if we have the other examples, just isolate the square term and take the square root. And again, remember I recommended working in reverse PEMDAS order, which is SAD MEP. The end. Thank you for watching my video.